Okay. Let's get into what we're going to do today. It shouldn't take too long today. Of course, I should always be careful when I say that, but it shouldn't take too long. And here we go. Today, we're going to look at solving exponential equations. So, equations with exponents in there. I'm on freeze. Unfreeze. Okay. So our big directions today are just going to be solve for x, or whatever your variable might happen to be. Okay. And we'll just jump right into an example here. Okay. So, let's see here. For example, let's say we have 8 to the x equals 2 to the 6th. And we're going to be solving exponential equations. How do I want to say this? Solving exponential equations without logarithms. Okay, because later we're going to be using logarithms. But for these ones we're going to do today, we won't need logarithms. Or will we? Oh my gosh, never mind. We are going to use logarithms. My bad. We are going to use logarithms. Blah. We'll get to that. Okay, sorry about that. I'm looking at the bottom like, yes, we are. Okay, so anyway. But we don't have to do for all of them. That's the key. Okay, we don't have to do it for all of them. So we want to solve this equation for x, for example. All right, 8 to the x equals 2 to the 6th. All right. Ideas here? How would we solve something like this? Jenna?
Find out what 2 to the 6 is and then make the other one equal.
Okay, so figure out like what 2 to the 6th is. So 2 to the 6th is 64. Okay. So yeah.
You can make the 8 2 to the 3.
Oh, we'll get to that. Let's finish this and then I see what you're saying, Jenna. Yeah, we'll get to that. But okay, at this point, we did what 2 to the 6th is, the 64. Now what can we do? Just kind of, you can do it in your head, maybe, right? Okay, what power of 8 gives us 64? 2, right? So this is really just x equals 2. Okay, you can just kind of know that. Okay, that's one way to do it. But Jenna, you said you were another idea here. What's another strategy we could have used? No, Jenna, you.
Oh.
But that was right. That was all. Yeah. That was your strategy. That's fine. That works, right? What else though? What are you gonna say, Jenna?
You could do 8. You can change it to 2 to the 3rd.
Okay, so rewrite 8 as 2 to the 3rd.
In parentheses.
And then 2 to the x, yeah? And then this is 2 to the 6th. Okay, so the goal here, right, is to take something, take the exponent there, 8, or take the base, 8, and rewrite it as 2, because we can, right? We can rewrite 8 as a power of 2, and then we also have a power of 2 over here, right? So essentially we're trying to get a common base. All right, so this strategy, you can say it's like rewrite the equation in terms of a common base. In this case, 2 was possible. Now, it's not always going to be possible to rewrite in terms of a common base, right? But in this case, we can. All right, so now let's simplify this a little bit. So we have then power to a power, we multiply. So it's 2 to the 3x equals 2 to the 6th. Okay, and now that we have two things that are equal, right? The left-hand side and the right-hand side are equal. They both have a 2 as their base. So their bases are equal, so what must be true about their exponents? They have to be equal as well, right? And so we can just kind of eliminate the bases and say, okay, well 3x must equal 6, and so then x must equal 2. Okay? Different way to do it. Takes a little bit longer, but that's one way to do it, yeah. Okay? That's another way to do it. Okay. And alternatively, anytime that you have an equation, right, that you're trying to solve, and if you don't have, like if you're allowed to use your calculator, anytime you have any equation, any kind of equation that you're trying to solve, you can use your graphing calculator to do it. If you've never seen this done, right? We can just take 8 to the x And we can take 2 to the 6. So in other words, graph both sides of the equation. Graph the left-hand side and y1. Graph the right-hand side and y2. Okay, and we'll graph it here. Okay, there's that 8 to the x, all right, our exponential growth there. And of course, 2 to the 6, we can't see it because 2 to the 6 we know is 64. So we have to adjust our window, okay, and 64, that's our y value there. And so we need to increase our y max to be more than 64, so I'll say 70. So we graph it here. Okay, so again, there's the left-hand side of our equation. There's the right-hand side of our equation. And where will the solution to this equation be located? Where they intersect. Exactly right. Okay, so we'll find the intersect by using the intersect command. Okay, let me just make sure I'm on the first curve. So I'm on the exponential here first, and then it jumps up to the 2 to the 6. And then for the guess, you're supposed to move in close to like the actual point of intersection and hit enter. And voila, 2 is our answer. X equals 2 solves the equation there. Okay, but of course we knew that already, right? But that is a nice thing that you can use. Whenever you have a graphing calculator, you can solve any equation you want. You can check yourself, too, by using your graphing calculator. Graph the left-hand side, graph the right-hand side, find point of intersection. All right, let's try another one. We'll again solve for x will be our directions here. And let's say we've got 7 to the 3rd to the x over 49 equals 1. Can we rewrite this equation with a common base? Can this equation be rewritten with a common base? Yes? Okay. So what's our common base going to be here? 7? Okay. So, well, 7 to the 3rd, that's pretty, yeah, it's already 7 as a base. We can then multiply the exponents there, make it 7 to the 3x. 49, is that a power of 7? 7 to the 2 equals, and then 1 is a power of 7? 7 to the 0, you got it, that's right. Yeah. Well, it looks like 7 degrees, I guess, the way I wrote it, but it's 7 to the 0 power. All right, so let's continue to combine things together here. How can we simplify that left-hand side? If we have division between two numbers with the same base, what can we do with their exponents? Subtract. Okay. And now we have 7 to the something equals 7 to the something. And so we can kind of drop those bases. 3x minus 2 equals 0. And so x is 2/3. Okay. And so there's our answer. Questions on any of that? Ready to try one on your own? Okay. I'm going to give you 2 to try. Number 1. 27 to the x equals the cube root of 81. And then number 2, 3 times 2 to the x equals 42. And you can use any method you want there to solve those. Anything anything we've talked about, anything we haven't talked about. Give those a try. And you can, if you want to, you can round your answer to 3 decimal places.
Without calculators?
You may use a calculator if you want. I can let you borrow one. So yes, let's see here. What do we have here?
27. I may be wrong. Just calculating it from memory.
You can. So you have the square root right there. So you have 2 options you can do here. First of all, instead of doing a cube root, that's the same thing as to what power? 1/3. 1/3. So you could raise it to the 1/3 power, or that's the math, but there actually is a cube root command, and then you can also then, if you put whatever number you get a fifth root or whatever, put a 5 first, then you go to that command. You'll need to put parentheses and stuff like that too, but yeah. Yeah. We have a couple strategies, right? You can try and get a common base. Graph, potentially.
It doesn't exist.
Doesn't exist? Which one? This one here?
Cube root, so
Oh, it does. You can use it with 1/3 power if you want to.
I can. It's like a decimal.
Oh, yes. That might. So you might want to try and get a common base there. Try and get a common base. Take a common base. Or you can graph it too. If you really want. I'm sorry. Okay. Gotcha. That's straight down. Yeah. Good job.
I completely forgot to break it.
Question. Yes.
So I've got the base. So now I have to figure out 3 times what equals 81. Or 3 to the what equals 81.
Right.
3 to the what equals 4.
So 81 is 3 to the 4th. But then you're also raising it to the 1/3, so it'd really be 3 to the 4/3 power, which would be right, because you have the power to it.
And I just like this time.
Yeah, you could do it like that if you want to. Yep, just like that. So you have 3 to the 3x equals 3 to the 4/3, and then solve it. So the power is equal to solve it. Maybe like 1 or 2 more minutes here, 1 or 2 more minutes. If you're stuck or anything, I'll be happy to run help. What do you think? Any ideas? Well, we're trying to solve for x, right? So maybe we should try call that typical kind of algebra solving equations thing. We want to try and get x by itself. Yeah, there you go. So that's what you're gonna think, maybe, if nothing else. Oh, you did. I see. Yeah, that's right. Now, which one? Either. Let me manage you real quick. Okay, but you have the right idea. Remember, everything is the power of 3 here. So then you have the power to a power, multiply the powers. So 81 is 3 to the 4th. So you can make that, 3 times 3 to the 3rd, so 3 to the 4th. And then power to a power, multiply the powers, and then go from there. So what's the problem here, Benji? Right, you can't really, there is a power of 2 that gives us 14, but like, I don't know what it is, right? So, but you can still solve here. You can have options, right? For example, you have your graphing calculator. If you want to like graph it and stuff like that. I'll show you how to do it without the graphing calculator, but for right now, I'm going to try and solve it that way. I'm just talking about that. Sorry? So you're on the right track. Oh, but we can't multiply these together. 3, because that's 2 to the x, and that's a 3. So 3 times 2 will not make 6. So you want to actually divide both by 3 first, and then try to graph it or something. Oh, question. All right, one more question here, and then we'll go over these. Okay. So number 1, do you have a common base that you can rewrite both of those numbers as? 27 is a power of.
Wait, can I do like?
Yes. more minute. One more minute here to give folks a last minute chance. Okay, here we go. Let's go to Caitlin
Wow. Okay.
for number 1. I mean number 3, but number 1. So you pass.
Yeah, I passed.
You had no idea here.
No, I thought I had an idea, but it's wrong.
What'd you try? Just real quick, and then we'll just see how wrong it is. We'll judge you. I'll judge you.
I tried to simplify the 27x, and I got 3 to the 3x.
Oh my gosh, that's the right first step.
Okay, yeah.
We can pass it on if you want to. So, but I mean, you are right for the first step there. Actually, let me take one. Let me take one more. So, 3 to the third, right, is 27 to the x, and when you have a power to a power, you can then multiply. So it's 3 to the 3x there. Yes. Okay. Did you do the same thing with 81?
I had 81 to the 1/3.
Okay, 81 to the 1/3. I'll put that here, I guess. But of course, 81 is also a power of 3, right?
Yeah.
3 to the 4. 3 to the 4. Yeah. One more. So again, 3 times 3 is 9. Times 3 is 27. Times one more 3. 27 times 3 is...
Yeah, I don't really know what I did. I just know I ended up with 3 to the 9.
Gotcha. It's 3 to the 4 to the 1/3, like that. Okay, 81 is 3 to the 4th, and then to the 1/3 because we have the 1/3 there. Okay? We have a power raised to a power. How do we simplify that, Caitlin? Yeah, so 3 to the 4/3. Okay? And then let's see here. After this, Tommy, we have the same base. Okay, 3 to the 3x and 3 to the 4/3. So what can we really write here then? What else? What's equal then from that? There you go. 3x equals 4/3. And so our final step here, Tommy, is to divide by 3. So we get x equals what there, Tommy? 4/9. You got it. Okay? All right. Good now, Caitlin, yes or no? Yeah? Okay. It's not on the quiz, so we can forget. You don't even have to worry about it now. Forget it. Eat, drink, and be merry. All right, let's go to May, number 2. May, did you get anything? Were you able to get anywhere with number 2?
I didn't get the answer, but I
Okay.
got 3.
What'd you do here?
So I changed 42 into 3 times 14. So
Okay.
3. Yeah.
So like this.
And then I just kind of set it up as 2 to the x equals 14.
Yeah, that's right. I mean, you could think of like dividing both sides by 3 if you want to or whatever there. Yep, 2 to the x equals 14. And then you kind of got stuck from that point. Right, why?
I don't know, I kind of know where to go. I don't really remember.
Okay.
But I remember having to do problems like this.
Okay. But what's the problem with this? The strategy that we've been using, right, which is like rewriting as a common base. What's the problem with right, yeah. 14 is not a nice power of 2. It is a power of 2. There is some number that if you take 2 to that power, you get 14. But yeah, at this point we're kind of stuck. Okay? So one option we could fall back on here, right, is to use our graphing calculators. You could graph the left-hand side, graph the right-hand side, find the point of intersection. Did anyone do that? You tried to, Natalie? Did you find a point of intersection?
I don't know.
What'd you get? Like, was it, what'd you get for your x value?
Looks like my calculator's actually, it
It's
is
giving you
here,
some-
but I
it's-
don't know if it's actually solving.
Okay, well, so 2 to the x, right? We can graph it, and then 14, right? Zoom 6 here. All right, there's 2 to the x. Of course, 14, though, if I go to the standard viewing window, 14 is going to be up here out of the graph, so I have to change my window. Go change my y max. I'll make it, I don't know, 20 instead of 10 there. And I should now be able to see, there's 2 to the x again. There's 14. And, of course, the intersection point, second trace, intersect. Okay, so our answer here, 3.807. Okay, approximately 3.807. Okay. 3.807. But of course, that's an approximation. We can, however, represent this precisely. Okay, we can represent this precisely. We can solve this, get the x by itself, and have like a precise value here, not some rounded decimal. Okay. What thing did we just learn that allows us to take the variable here out of the exponent? Logarithms, right? It's that third property of logarithms. Log base a of u to the n equals n times log base a of u. And if that n happens to be x, our variable here, same thing applies. Okay? The question is, though, what logarithm base should we use?
2.
We can use 2. Okay, so Ethan, why'd you say 2?
Because it's 2 to the x power, so then
Yeah.
log base 2 each side.
Yeah, so we could use log base 2 here on both sides because our base of our exponent is 2. So we could say, okay, let me go up here. We could say log base 2 of 2 to the x equals log base 2 of 14. Okay, so we take the log of both sides. And we use log base 2 in this case. Okay, log base 2 of 2 to the x, or in other words, 2 to what power gives us 2 to the x? This just simplifies to x. Okay, and then we have a precise value over here of what x is. X is precisely log base 2 of 14, or in other words, 2 to what power gives us 14. That's exactly the same thing, right? That is the value. And if you, again, type that in your calculator using change of base, remember we know how to do this in our calculators. Even though it's log base 2, you can go to your calculator and type, log 14 divided by log of 2. And there it is, that 3.807. Or you could do natural log of 14 divided by natural log of 2. And there, same thing, right? 3.807. That's that change of base that we talked about on Friday. Okay? Here's the thing, though. You don't have to use log base 2. Go, question, Jenna.
How did we get the base 2?
Because the exponential equation that we're trying to solve, it was already a base 2. So we use log base 2 to kind of cancel out easily there.
Okay.
So the logarithm, we match the logarithm to the base of that exponent. Okay? So, alternatively, though, Jenna, you don't have to match them. So, for example, let's just say I had that 2 to the x equals 14. Okay, and let's just say that I just use logarithm, which is log base 10, right? Let's just say I said log of 2 to the x equals log of 14. So let's say I didn't care about trying to match them. Okay, you don't actually need to. I can still use the property of logarithms here, right? Log of something to a power, I can bring that power out front and make it x log 2 log equals log 14, like that, right? Bring the power out front using our properties there. And then we have x times log 2 equals log 14. So to get to x by itself, what should we do to both sides here? Divide both sides by log 2. Okay, that cancels, and we're left with x equals log of 14 over log of 2. These two things are equivalent, right? This is the change of base for this, right? This is log base 2 of 14, this value. But if I wanted to change it to log base 10, this is exactly what I type in my calculator. Right, I'll show you here. Math. So let's do log base 2 of 14. There's that value. But I could also do log of 14 divided by log of 2. See, same thing. It's change of base. So it ends up being the same. So in other words, Jenna, you don't have to match the base if you don't want to. If that makes it easier, hopefully. All right, let's try another one here. To make sure we've got the idea. Let's solve for t in this case. 6 parentheses 2 to the t plus 5 plus 4 equals 11. Yes. We can do this. You can do it, Mr. Wade. Okay. Rohan, do you have any inkling about how you should maybe start with this? No idea? If you were trying to solve this, if you're like, gun to your head, water pistol to your head, all right, and you're like, you gotta solve this or else you're gonna get really wet. What would you have to do? Oh my gosh, and you're exactly right. Subtract 4 from both sides. This is also being recorded, so if you guys want to go back and like get me fired, you can, just play this for the play this. Hey, Miss Claylaw, guess what Mr. Witt said in class today? There it goes. All right. That's right, first step. And I say goodbye. There's my job. All right. Okay. What next, Rohan? What do you think? Divide by 6. Now I'm lost. Now I give up, Mr. Wid. This is just like what we had in the last one, though. What do we need to use at this point? Can we rewrite 7 6 as a power of 2? Not easily, right? So we need to use a logarithm. Okay? Does it matter what logarithm you use? No. You can use natural log. You can use log base 2. Okay? Log base 2 would maybe be the most kind of natural one to use here because we have 2 and then the exponent has the t plus 5 in there. You don't have to though. Okay? So you could use log base 2, natural log, any base you want to use. Okay? So I'm just going to I'll use natural log here for this one just to change it up. So I'll do natural log of both sides. If you do choose to use log base 2, it does slightly change how you're going to solve the problem. All right, so if you do choose to use log base 2, if you do choose to match your logarithm's base with the exponent base, it slightly changes how the answer is going to turn out, but the value will still be the same. The way you solve will be slightly different. Okay? All right, so now we've used a logarithm, though. That t plus 5 exponent, what can we do with that? Bring it out front, exactly right. So we're going to have the quantity t plus 5, natural log of 2, equals natural log of 7 6. Okay? And again, we're trying to get that t by itself. Okay? So Rohan, you're a good sport. Even though I threatened you with the water pistol, we'll move on here. Ro, do you have an idea about how we should proceed from here? Get the t by itself. What's with the t that we need to get rid of? Yes, divide both sides by natural log 2. You're right. I run out of space here, so I'll have to do it up here. So yeah, we're going to have t plus 5 then equals natural log of 7 6 over the natural log of 2. You got it. And then Ro, what's our final step there?
Then you're going to minus 5.
Yep, you got it. Subtract 5 both sides. Okay, and so our precise answer will be natural log 7 6 over natural log of 2 minus 5. That is precisely what t's value is going to be. Or if you want to type it into a calculator, you'll get a decimal of about -4.778.
Would we have to simplify it like it was in the middle? Like with the LNs?
Like rewriting it as a single natural log or something like that? Or well, this one you can't, unfortunately, because the natural logs are being divided, and we have no properties for when 2 natural logs are being divided. We only have a property when two logs are being added or 2 logs are being subtracted. Then we can rewrite them as a single one. But when you have 2 that are being divided, we have no property. So you're kind of stuck at this point. So good morning, Mr. Goff.
Good morning. Lydia and Nolan.
Oh, playing around.
Yes.
Nice. So this is what we're doing today.
Yes.
Okay. This is extra from the packet. Okay. You guys got through the whole packet?
No.
Okay. But this is just extra. Okay. Thank you.
Mr. Rick, can you show us what the answer would be if we use the other one? With log of the
Yeah, if we use log base 2, sure. I'll just squeeze it in right over here. So yes, if we had chosen to use log base 2 at this point, okay, so we'll still write log 2 of 2 to the t plus 5 equals log 2 of 7 6. Okay. Now, when this simplifies, what's going to be left over? What is it?
t plus
Yeah, just t plus 5. Okay, and so now there's only one more step we have to take in order to solve for t. Just subtract 5 on both sides. And that's our final answer, precisely.
You mean minus 5?
I do mean that. Okay, now it looks like a 5. All right, anyway. So that's the idea there. Okay, so subtle differences. If you do match your log's base with the base of your exponent, then that base will completely cancel out and you're left with just the t plus 5, just the exponent there. Okay, but if you use a different logarithm, a logarithm with a different base than what you have right here, the 2 will also remain. You'll just end up dividing it over and then subtracting the 5. But you can see that this quantity right here, again, according to our change of base, this quantity will be equivalent to this quantity right here, right? If you want to change the base 2 here to like a base e like we do with the natural log, this is exactly what it would be. Log 7/6 over log 2, or natural log 7/6 over natural log 2. Okay? Questions on any of that? I got one more I want to show you here. Just didn't have enough space. So we'll just start a whole new sheet. But it's just for one problem. Last problem. All right. Same directions, solve for x. E to the 2x minus 3e to the x plus 2 equals 0. Okay, last one. Yes, exactly right. Yeah. Yeah. Natural log is log base e. This is a little bit weirder than the other ones. All right. Do we have any like terms we can combine here? Yeah, not quite. We do have 2 base e's. Well, the problem is one of them is e to the 2x, one of them is just e to the x, and so they're not exactly the same. Okay, so we can't really like combine anything here, and so if we were trying to solve this, we could like subtract 2 on both sides, but the problem is we would still, like we could do this, right? Subtract 2 on both sides, and at this point we can maybe like, well, maybe if I take a natural log here of both sides, we can already see some weird stuff's going to happen because, well, first of all, the natural log of 2, what's that going to be? Natural log, sorry, negative 2. Yeah, what's that going to be? Or in other words, e to what power gives us a negative 2? It's impossible, right? Impossible. Yeah. And also over here, right, again, I can't take the natural log of these individually here. So these like 2 pieces right here individually, I can't take the natural log individually, right? It's the natural log of the entire side. It's the natural log of the left-hand side equals the natural log of the right-hand side. Just like if you square root both sides, right? You can't square root individual terms. It's the square of the entire left-hand side, the square of the entire right-hand side. And because we have subtraction inside the logarithm, do we have a property for breaking up subtraction in the logarithm? No, we don't. Okay, so this is not a good way to go. Okay. But the formatting of this problem should be a little familiar, right? Yeah, we're going to factor it. That's right, our favorite, the F word, factor. Okay, so here we go. All right. If you don't see it, let me maybe rewrite this for you in a formatting that would maybe make some sense here. So e to the x squared, right? Isn't that the same thing as e to the 2x? Minus 3e to the x plus 2 equals 0. Or maybe blank squared minus 3 blank, bless you, plus 2 equals 0. It's a quadratic form. Bless you, bless you. Okay. So we need to think of 2 numbers that multiply to positive 2, but add to make negative 3. So it'll be negative 1 and negative 2. So we'll have e to the x minus 1 times e to the x minus 2 equals 0. Exactly. And so we can then set each one equal to 0. And so e to the x equals 1, e to the x equals 2. And so now to solve, what should we do at this point? get the x by itself there, what should we do? Natural log both sides. That's right. So we'll natural log e to the x, natural log of 1. Natural log of e to the x is just x. What's natural log of 1? 0. Yeah. E to what power gives us 1? E to the 0 gives us 1. Okay? And then natural log both sides here, we'll get x equals the natural log of 2. And natural log of 2 is not so easy to simplify.
How do we do that again?
How do we do it again?
After like,
Here, here, here.
yeah.
So e to the x equals 1. You got that. We natural log both sides so that we can get that, cancel out the e and just make the x equal something, right? Like the natural log of e to the x is just x.
Yes.
Okay? Natural log of 1, how do we evaluate that then, right? So natural log, remember, that's log base e. So e to what power is 0? Oh, sorry, e to what power is 1? E to the 0 is 1. So that's why they find out to 0. Question, Ro? I just skipped that step. Just because we did it right there. I can write it here, though. There you go. Okay, and that's it. And that's as nasty as it's going to get there, right? But now that you've seen it, it won't be that hard at all. Wrong? Well, let's maybe practice here some. So I'll give you guys your assignment. Okay. Now remember, this will not be on tomorrow's quiz, but it will be on a future assessment, almost certainly, right?